All right. Good afternoon again, everyone. How was your weekend? Kumusta ang Sabado at Linggo? Did you had some chance to relax? Or dahil nagbigay ako ng homework ng Friday, napilitan kayo mag-work ng weekend? So, how was it? Sabi guys, magano naman kayo, mag-react man lang or hanapan ko kayo ng ambag sa klase na to. Sige kayo. At talagang ang tipid nyo, no? Reacts lang talagang ibibigay nyo sa akin. Uh, Mine was good by then. I mean, I was not feeling well Thursday and Friday. Tapos sabi ko weekend naman, and usually I don't want to work during the weekend. So siguro mga 10% work lang ginawa ko ng weekend. Kaya lang, yung mga natambak kong trabaho ng Thursday and Friday are finally catching up with me yesterday and today. So kaya medyo hindi na pala masaya yung weekend ko. Kasi naalala ko habang nagbi-binge watch ako sa YouTube ay ang dami ko palang trabaho na hindi ginawa. Pero anyway, that's the weekend. So that's really for me to relax. Yun nga lang, medyo hindi ko pa nasimulan yung mga dapat kong gawin, ay yung mga dapat kong ginawa ng Thursday and Friday. Including the homework. So I'm sorry everyone for not uploading the homework as promised Thursday. So nung Friday na-upload ko naman siya, so the deadline for that homework would be tonight, all right? Wednesday, ano ba ngayon? Tuesday, all right? And then will it be all right with you if we keep that schedule na lang for the rest of the semester? I mean, I'll give you the homework on Friday, sometime Friday, okay? Basta Friday pa yung nasa kalendaryo, mag-upload ako ng homework, and then the deadline would be on Tuesday, the coming Tuesday. Para yung mga nagma-math 175 ay may nag-request kasing ilan para hindi daw magsabay kasi sa math 175 namin every week, every Monday, they have to submit a laboratory exercise. So para hindi masyadong magahol or makram sila, i-move natin yung sa 155. All right? So how was homework 3? I hope you guys started doing it. Doon nga pala sa homework 3, hindi kailangan ng justification, hindi kailangan ng proof. So ang gagawin ko lang ay hahanapin ko yung sagot nyo doon sa apat nga bang tanong yon, yung nasa part 1. So basically, it will become all or nothing. I'll ignore all your explanations. Titingnan ko lang yung final answer. So, madali siyang sagutan kasi hindi nyo na kailangan mag-set ano yung mga kailangan kong justification for all of those answers that you have. Okay? Pero yun nga, yung cost nun ay nagiging all or nothing siya. Okay? So if you don't have any questions with that, so probably we'll start with, or we'll continue our discussion about the last few portions of lecture notes 1 or the unit 1, which is basically our reconstruction of the set of real numbers. So just a brief recall. So last week, we talked about, among other things, yung limit points ng isang function. Okay? Limit points, sorry, hindi functions. Limit points ng isang set. So, nadulas ako, limit point ng functions kasi nga parang ito yung precursor, ito yung mas general type of limits, limit ng sets, all right? Mga limit points ng set. Pero sana ma-realize nyo later na, oo nga, no? Ang mga functions nga pala at saka, mga functions at ang mga sequences ay hindi talaga sila yung mga formulas. Sila ay mga sets, all right? And then they are set of points, and then yung konsepto ng limits natin na hindi talaga computational. Nanggaling sila sa konsepto ng limit points ng isang set. Yung limit ng isang function actually is the limit point of the function interpreted as a set. So parang generalized yung version. Kaya lang, ang maganda dun sa elements ng set, pag nagpunta tayo sa functions, may formula na nagde-define dun sa mga element ng functions. Alright? Kaya nagagawa natin computationally. Unfortunately for us right now, we are considering arbitrary sets na walang distinguishing characteristics yung mga laman nila. Aside from probably a couple of inequalities and so on, pero ito yung pinaka-generic na version ng definition ng limit points. Corollary niya lang or direct consequence niya lang yung mga limits ng functions, sequences, and so on na natutunan natin sa calculus. All right? Now, we say that a set X is a limit point, right? Or in other words, we can say that a point X is an element of the derived set. Remember, kapag ka meron kang A tapos may primes sa tabi, ang tawag natin dito ay derived set of A, which is basically the set of all limit points of the set A. So if I write something like this, I mean that X is a limit point of A, all right? And this is characterized by the existence of some elements of capital A in any neighborhood around X. So bale yung technical definition natin dito kapag ka si X ay limit point ni A, for any given epsilon, however small it is, there will exist a Y different from X such that Y belongs to the intersection of the epsilon neighborhood around X and A itself. So basically, tiningnan natin to, mga limit points, sila lang yung mga accumulation points. Sila lamang yung cluster points. Ibig sabihin, sila yung mga members ng set of real numbers kung saan nagkukumpul-kumpulan yung mga elements na capital A. Bakit nagkukumpul-kumpulan? Bakit ganito yung technical definition natin? Kasi nga, kahit maliit na epsilon neighborhood, meron siyang laman na element ni capital A. Kahit anong epsilon neighborhood ni X, however small it is, will always contain at least one more element of A except possibly for X. So pwede niyong isipin si X, kapag ka si X ay limit point, para siyang sikat na artista na maraming fans na laging nakapalibot sa kanya. All right. Marami siya meron siya laging mga kapitbahay na elements ni capital A. Or yun nga, para siyang mga celebrities na hinahabol lagi ng mga fans nila. Yes, Elmira?
Sir, excuse me lang po. Nawalan po kasi ako ng connection and pagbalik ko po, hindi ko na po makita yung shared screen niyo.
All right. No worries, Elmira. Thank you for calling my attention. So,
Thank you,
sige.
sir.
Restart ko lang. Mahirap makinig ng ng walang nakikita, no? Yeah. Okay. All right, and I want you guys to, of course, first appreciate the definition of a limit point. Okay. Tapos kasi pag na-appreciate niyo yung definition ng isang limit point or any definition, or any other definition, mas madaling isulat yung kanyang technical description. All right? And be familiar with this technical description because I will be using it repetitively in the proofs that we will do later. Okay? So ito ay si X ay limit point, si X yung nasa gitna ng epsilon neighborhood, may makikita kang element na Y na different kay X na member ng intersection nito. And at this point, I hope you are feeling smart kasi etong buong sentence na to, kahit wala kang letter na nakikita, naiintindihan nyo yung ibig sabihin nitong parang just a few gibberish or alien-looking symbols. Pero nagkakaintindihan tayo na pagka nakita nyo to, ibig sabihin si X ay limit point. All right. Okay. Limit points. What's next after limit points? Another thing about limit points, they do not necessarily reside on the set A. Posibleng may mga elements na wala kay A pero limit point sila ni A. Hindi required ang membership kay A para maging limit point. Okay? Remember dito, ayaw nga natin na si X yung maging intersection nung neighborhood at saka nung set A, right? Kasi nga in the first place, X might not be in the set X itself. All right? Now, kapag ka meron tayong element ni capital A, but not the limit point, okay, we call X is an isolated point. Okay, isa siyang isolated point ni A. So, isang isolated point ni A. Isang isolated point of A. Alright? So, ibig sabihin, wala siyang kapitbahay. Merong isang neighborhood around A na wala siyang kapitbahay. But again, the requirement for an isolated point, dapat mag-belong muna siya dun sa set A. Because if an element is outside of the set A, then there's no chance that it will be an isolated point. All right? Okay, And then the last thing we talked about last time is the closure of a set A. The closure of a set A is written A bar, okay? And by definition, it is simply the union of A and A prime. So basically, ang laman ni A bar ay yung mga laman ni A at saka yung mga limit points ni A. Collectively, this set is called the closure of the set A. Okay? So yon yung kailangan natin ngayong pag-aralan. Ano yung mga magagandang properties ng closure ng isang set? And we will be greeted with Theorem 13. Theorem 13 says, ang closure ng isang set ay closed, which will sound obvious kasi kaya pala tinawag siya na closure kasi closed siya. All right? So but essentially it is closed and it is the smallest closed set containing A. So if we'll be proving 13, actually we will be proving two things. First, we want to show that A bar is closed. And second, we want to show that it is indeed the smallest closed set containing A. Or what I'll do in the proof is to show the impossibility of having a set that is a proper subset of A bar that is closed and that is a superset of the set A. All right, so yun yung gagawin natin in Theorem 13. Okay, prove ko siya dito from scratch and I hope you will engage with me when writing the proof kasi medyo mahaba yung proof. I might be lost in some steps, so hopefully you will help me out. Okay, and as I've noted earlier, our proof will be twofold. First, we're going to prove that A bar is closed, okay? So first, we want to show that A bar is closed or is a closed subset of R. Now, what does it mean to be closed? Can anyone remind me, kailan nga nagiging closed ang isang set? Guys, bonus points. So, aambag na kayo. Yes, Tristan?
Hello sir, rinig po ako?
Yep, go ahead.
A set po is closed if it contains all of its limit points po.
All right, thank you, Tristan. Yeah, luckily sa atin, kokonti pa lang yung alam natin about closed sets, right? So that we can work that out to our advantage. So, yun pa lang ang alam natin, definition ng pagiging closed. Gusto kong ipakita na si A bar ay closed, so I want to show that A bar contains all of its limit points. That's going to be my strategy here, all right? So I want to show that A bar contains all of its limit points. So therefore, one strategy or one thing that we can do is to consider a limit point of A bar. Consider an X that is a limit point of A bar. And we want to show that X belongs to A bar. Maybe I should put that here in parentheses. We want to show that X is in A bar. So ang idea, nag-consider ako ng isang arbitrary, isang generic na limit point ni A bar. Tapos sabi nga ni Tristan, para mapakita na closed si A bar, dapat mapakita ko na itong arbitrary limit point na to ay nasa loob ni A bar. Alright? Yun yung very definition of being closed. Alright. Now that's the goal. Consider X is in A bar. Now, what can I do next? Well, I'll work with my assumption that X is an element of A bar. Ibig sabihin, si X ay limit point ni A bar. So, ibig sabihin, for any epsilon, siguro lagyan ko ng so para maganda yung flow. So for any epsilon greater than 0, i-apply ko lang yung definition ng pagiging limit point. Pero be careful, limit point ni A bar. Alright? So here, for any epsilon greater than 0, there exists a y different in x such that y is an element of the epsilon neighborhood around x intersection A bar. Alright? Kasi nga si x ay limit point ni A bar, so may mga elements si A bar na nagkukumpul-kumpulan sa kahit anong epsilon neighborhood around x. Alright? So I hope everything is fine. Direct use of the definition of a limit point. Alright? And the next, ano yung alam natin from here? Well, alam ko kung ano yung itsura ni A bar. Can anyone refresh me what is A bar? Ano nga si A bar? Closure ni A. But what can we say about the closure? Yes, Perlene?
Siya po ay union ng elements ni A at saka po ng limit points.
All right, thank you, Perlin. That's perfect. A bar, the closure, is the union of the set A and its derived set, o yung set nga ng mga limit points ni A. All right. Tapos ito na yung form. Well, parang walang mas natural na gawin kundi i-perform yung set operation. So babalik tayo sa 101. Paano nga ba tayo nag-distribute ng union over ng intersection over union? So I'll do the math for you. So this means Y is an element of the epsilon neighborhood, intersection A. Tapos yung sagot, i-union ko naman sa epsilon neighborhood, intersection A prime. All right. Now, Y is an element of the union, and hopefully tandaan nyo pa sa 101. Kung hindi, isusumpa ko yung mga estudyante ko rito last semester. Pagka meron tayong union, ang connective doon ay OR, right? When Y is an element of the union of two sets, then Y belongs to either of the two sets. So either Y belongs here or Y belongs here. Okay? So meron tayong two possible scenarios. We are not sure which one of those two nagbe-belong si Y, pero sure tayo, at least isa sa kanilang dalawa. Kaya lang, di natin alam exactly kanino. All right? So that means, if I will just assume that this is true, then I will be leaving the possibility of Y being in here. So kaya, sa mga susunod na parte ng proof, kailangan kong hatiin to sa dalawang cases. Dalawang independent cases. Y belongs here or Y belongs here. And then in either case or in both cases, I want to show that X is in A bar. Yun yung magiging atake natin. Pero kailangan ko siyang gawin sa both. Kasi nga or yung connective. Okay? Kung and, pwedeng pumili lang ako ng isa. Pero unfortunately, or yung connective. Okay? So a little review of logic there. So that means I am forced. So period ko na to. Tapos case 1. Let's investigate what happens when Y is an element of the epsilon neighborhood intersection A. Okay? And I think this is easy, but I want you guys to think about what conclusion can I draw from there. And I'll highlight some clues, okay? Or meron bang mag-volunteer na? Sige nga. Without the clues. Anong pwede kong masabi right after this? Under this, nagamit ko na yung so. It follows that what happens? Okay, kung gusto niyo ng clue, ito yung clue. For any epsilon greater than 0, there exists a y different from x such that this guy is true. Yeah. Ano yung ibig sabihin nung highlighted symbols there? Okay, sige, antay lang ako, Perlin, ng ibang volunteer. Pag wala, ikaw na yung tatawag nyo. Yes, Noriel. Nakita ko yun, tapos binaba niya bigla. Sorry, mabilis yung mata ko ngayon.
Sir, X is a limit point of the set A.
Alright. That's perfect, Noriel. And yun din yung sabi ni Jonathan. So, thank you rin, Jonathan. Yeah. Itong highlighted portion means that Y is not just, it means that X is a limit point of A. It follows that X is an element of A prime. Sabi nga ni Jonathan sa comments. All right. So if that's the case, then we are sure that X is an element of A bar. Kasi nga, remember, si A bar ay A union A prime. Pag nagbelong ka na kay A prime, sure tayo nandun ka na sa union. So nagbelong na si X kay A prime. So nandun na siya sa union, which is the closure. And I guess that's what we wanted to show, right? We wanted to show that X is in A bar. So there's no big deal if Y belongs to this guy. Now I think the more challenging part is for the other case. Let's assume that Y is an element of this guy. Okay? So any suggestion? Ano kaya yung pwede nating makuha from this statement? Dun sa case 2 na si Y pala ay ano mangyayari kapag ka si Y naman ay nasa intersection ng epsilon neighborhood ni X at saka ni A prime. Crew moment. Sige, isip-isip lang. Okay, syempre, ang isa sa mga natural na bagay na gawin ay copyin ko kaya yung ginawa natin sa proof kanina. Tingnan ko yung for all epsilon greater than 0, there exists a y different from x such that this is true. Pero ano yung statement na ibibigay sa akin nun? Ano ibibigay sa akin? Ito plus ito. Ang sasabihin niya sa akin, si x ay element ng what? Or si x ay blank ng blank. Pag kinopya ko yung ginawa natin sa case 1. Kung gagawin ko yun uli, ang makukuha ko ay si x ay element ng a prime prime, right? Or x is a limit point of a prime. That could be worked out. Doon problema ko lang doon ay hindi ko pa alam kung ano yung a prime prime. Wala pa tayong theorem na nagsasabi kung saan equal si a prime prime. Okay? So basically, yeah, we'll need to create another path forward for case number 2. Okay? Now, ano pa bang pwede kong gawin dito? Parang wala na, no? Hindi ko talaga pwedeng kopyahin yung ginawa ko sa case 1. So ngayon, tingnan ko na lang ito. I think we don't have any choice but to dissect this statement. All right? So if this is true, okay, then I can say that y is an element of a prime. Right? Medyo off nga lang dun sa gusto nating mangyari kasi ang gusto natin sana mangyari ay maging parang kamukha nito, right? Kung si x yung naging element ni a prime, then we are done, just like what happened in case number 1. But unfortunately, we cannot do that here. And I was only able to conclude this part by definition naman ng intersection. Nothing fancy about these two steps. Set theory lang yung ginamit ko. All right? Element ka ng intersection, so element ka ng parehas na sets. So, ibig sabihin, I'm sure that y belongs to a prime. Okay? Tapos, ano yung ibig sabihin ng y element of a prime? Ibig sabihin, si y ay isang limit point ni a. Sa paligid ni y, maraming nagkukumpul-kumpulan na elements ni capital A. Alright? So, tingnan natin yung picture. Pag hindi ko na talaga kaya siyang gawin in symbols, wala na maisip na arguments, wala na maisip na trick, ibig sabihin, kailangan kong pagganahin yung aking creative juices. So, kailangan kong pigayin yung utak ko ng isang clever way on how to deal with this, with the information that we have. And usually, lalo na sa analysis, I like to create a visual representation of what is happening para ma-discern ko ano ba dapat yung isusulat ko na argument. Okay? So, what happened here is nagsimula tayo sa element x. Tapos si y ay element netong dalawang sets na to. So ibig sabihin, unang-una, si y ay element ng epsilon neighborhood ni x. So ibig sabihin, formula rito, hanggang kay y ay mas maliit sa epsilon. So siguro yung epsilon ganyan kahaba. Kasi dapat ang condition lang naman si y ay nasa loob ng epsilon neighborhood ni x. So that means the distance between x and y is smaller than epsilon. But of course, nasasanay na tayo ng epsilon ay isang maliit na positive number. So imagine niyo na lang na ito ay nag-zoom in ako para mas madali siyang illustrate. Okay? But what will happen here can be scaled down para siya ay maging isang maliit na epsilon. Okay? Now, ano pa yung alam natin? Ano yung bago nating na-discover sa case na to? Or what makes this case different from case number 1? This case requires y to belong to a prime. Okay? So ibig sabihin, si Y ay hindi necessarily member ni A, kaya hindi natin nasabi na limit point ni A si X. Okay? Pero alam natin si Y ay limit point ni A. Ibig sabihin sa paligid ni Y, may mga nakatirang members ni A. Okay? So ito si Y. Parang si Y ay artista yan. Marami siyang mga followers, marami siyang mga fanatics na laging kumukumpol sa kanya kahit saan siya magpunta. Alright? Sila yung mga elements ni capital A. Mga elements ni A na super fan niya, stans niya yung mga elements ni capital A. Andito silang lahat. Sumasama sila palagi kay Y. And then you can think of X as isang kandidato. Kaya gusto nila yung mga celebrities Y para panghatak ng mga fanatics ni celebrity Y. Alright? So ganun yung nangyayari. So, yun pala, yung mga information na meron tayo, napakasimple pala ng geometric interpretation niya. Remember, gusto ko mapakita na si X ay limit point ni A. Kasi pag si X ay limit point ni A, sure na tayo si X ay nasa closure ni A. So, hindi nga tayo sure na may mga elements si A na nakapaligid kay X, pero sure tayo may mga limit points, namely Y, si A na nakapaligid kay X. So si Y na limit point ni A ay nakapaligid kay X. Kaya lang si Y, being a limit point of A, lagi siyang may mga daladalang elements ni capital A. So yung mga daladala niyang elements ni capital A, pwedeng sila yung i-consider ko na elements ni capital A na nagkukumpul-kumpulan around X. So parang nagiging cluster point or accumulation point si X by association dun sa isang sikat na celebrity na si Y. Alright? So kaya nga yung mga kandidato natin ngayon, lagi silang mayroong mga celebrities na panghatak, right? Kasi nga may following yung mga celebrities na yan. So I'm not saying that's exactly what is happening, but intuitively you can make sense of it that way. All right? Analogy lang, pero not always true, all right? In the case of celebrities and so on. Okay? Pero yun yung idea rito. So ibig sabihin, kailangan ko itong i-formulate mathematically, right? Parang, okay, nakikita ko na dito sa argument na to, at least sa drawing na to, si X pala ay limit point din ni A. Kasi yung mga nakakumpul na elements ni A kay Y, pwede ko silang bilangin as the elements na nagkukumpulan around X. Okay, so I just need to build a mathematical language for it. So siguro, paano ko siya sasabihin? Well, kailangan ko kasing ma-define na saan nanggagaling yung mga elements ni capital A na nagkukumpulan around X. Well, pwede kong i-consider to be an epsilon star neighborhood. Masyado pa ng maliit. Sige, lakihan ko na lang sa scale ko. Etong length na to, tatawagin ko yung epsilon star. Okay? So, dun sa epsilon star neighborhood ni Y, maraming mga nakalagay na elements ni X. Pero ang gusto ko ngayong mangyari, yung epsilon neighborhood around Y ay maging nasa loob ng epsilon neighborhood ni X. In other words, I want to choose epsilon star to be small enough so that it will fit inside the epsilon neighborhood of X. Or more properly, gusto kong piliin si epsilon star to be small enough so that the epsilon star neighborhood around Y, namely this interval over here, will fit inside the epsilon neighborhood of X. Kasi pag medyo napalaki yung choice ko ng epsilon star, tapos lumampas na dito, halimbawa ito na yung epsilon star kung pinili, napalaki yung epsilon star, posibleng yung mga hakot ni element Y ay mapunta rito. Eh nasa labas na siya ng epsilon neighborhood ni X. So hindi ko na pwedeng bilangin yung mga nagka-cluster around kay Y as mga points na nagka-cluster around X kung nandun sila sa labas ng epsilon neighborhood. So I want to choose epsilon to be small enough so that yung mga elements ni A na nagka-cluster around the point Y will also belong to the epsilon neighborhood centered at X. So that's why I really want to be very careful in selecting epsilon star. Okay? And I guess I can do it safely this way. So I can I can do it this way. For any epsilon star greater than 0, and bigyan ko ng conditions si epsilon star. Palitin ko lang to. Okay. Alright. And ano yung condition ko sa epsilon star? Gawin ko siyang mas maliit kesa sa minimum netong dalawang numbers na to. Well, I don't want epsilon star to be very big. So maybe I'll restrict it to be smaller than the minimum between the distance between x and y. So pag tiningnan natin yung distance between x and y, ito yan. Pag yung epsilon star ay pinili ko to be smaller than the distance between x and y, so yung epsilon neighborhood ni y, okay, ay hindi lalampas ng x. So kasi nga yung epsilon star ay hindi lalampas ng distance between these two guys. So yung epsilon star mas maliit sa length na to. So sure ako ngayon yung epsilon star neighborhood centered at y, posibleng hanggang dito lang or hanggang dito lang. Hanggang dito lang, hindi siya lalampas ng x. Though pwede pa rin siyang lumampas ng konti, basta wag siyang lalampas ng epsilon ng x minus epsilon. Alright? Pero I don't care about larger objects. I want to keep it as small as possible. Alright? Posibleng mas maliit, may malalaki pa kayong sets na makikita or epsilon star na makikita, pero I just want to see a small enough epsilon star. Okay? Doon ako sa safe side. Okay? And the other thing is that I don't want to go beyond x plus epsilon. Okay? Ayoko lumampas kay x plus epsilon, yung epsilon star neighborhood ni y. For the reason I mentioned earlier, kasi pag lumampas yung epsilon star, hanggang dito yung epsilon star neighborhood, posibleng yung mga elements ni A, dito sila nakasulat. Nasa labas na ng epsilon neighborhood. Kaya lang anong haba nito? So gusto ko yung epsilon star ay hindi lalampas dito. So ito na yung maximum na haba ni epsilon star. Okay? Let's see how long is that. The whole thing is epsilon distance long or epsilon units long. This guy is absolute value of x minus y long. Ibig sabihin ito ay epsilon minus absolute value ni x minus y. Alright, is that clear? Okay ba yung graphical explanation? Or nakakunot na kayong ngayong lahat? Okay ba? Or do I need to go over it again? Or is it fine? Kaya gusto kong gawin yung proof ng live para makita niyo yung explanation kesa nakalagay na sa book or naka-print na ganito yung proof. Alright? But I hope the analysis makes sense. Tahimik kayo. Kinakabahan ako. Pero feeling ko magagaling naman kayo. So sige na nga. I'll assume that everything is fine unless somebody will react. Okay? Okay so far? Okay. So if that's the case, then all right, so we'll have this. Now, with this restriction in epsilon star, it follows that kaya ako pinili si epsilon star to be that way is so that the epsilon star neighborhood around y would be a subset of the epsilon neighborhood around x. Tapos dito niyo makikita, okay, kaya pala gusto ni sir na ganun yung epsilon star. Gusto kong ganun yung epsilon star para yung epsilon star neighborhood ay nasa loob ng epsilon neighborhood. Pero remember, magkaiba yung centers nila. Yung isa centered kay y, yung isa centered kay x. Okay. But going back to this, y being an element of A prime. So then, siguro i-recall ko yan dito. Since y is a limit point of A, then ito na naman yung definition natin for all epsilon greater than 0, but I have chosen now a specific epsilon. All right, mag-work kasing definition ng pagiging limit point ni A sa kahit anong epsilon. So mag-work siya sa kahit anong epsilon star or kahit ano pa man si epsilon star kasi si epsilon star ay greater than 0. So then there exists, say, a Z different from Y such that Z belongs to the epsilon neighborhood centered at Y, intersection A. Ang reason, kasi nga si Y ay limit point A. Tapos meron akong specific epsilon na naisip. Okay? So, ang ibig sabihin nito, si Z ay nandito at saka si Z ay nandito. Alright? So, si Z ay na kay A, that's fine. Let's just put it aside for now. Pero si Z ay element nito, pero look at the subset relation I have established by choosing epsilon star nicely. I know that the epsilon star neighborhood of Y is a subset of the epsilon neighborhood of X. So that means if Z belongs to this set, then Z must also belong to this set. Z belonging to A, so ibig sabihin, si Z ay nandun sa intersection ng epsilon neighborhood ni X at saka ni A. And then ito na naman, mag-highlight na naman ako. Oops, ang layo pala. For all epsilon greater than 0, there exists a Z different from Y. Okay? Actually, kulang pala yon. Iput ko yung end. And Z different from X as well. Bakit si Z ay different kay X? Kasi nga, yung epsilon star ay pinili ko to be the minimum between these two guys. So, ibig sabihin, imposible na si Z ay maging equal kay X. Yung pala yung dahilan kung bakit ayokong lumampas kay X, kahit pwede pa sana. Pero gusto kong wag siyang lumampas ng X para hindi mabilang si X among doon sa mga possible Z's na nandun sa intersection ng epsilon star neighborhood at saka ni A. So now going back dun sa naunsyaming pagpapakitang gilas, alright, for all epsilon greater than 0, there exists a Z different from X such that Z is an element of this intersection. That should sound familiar because that implies that Z is, not Z, that X is a limit point of A. All right? Does that make sense? Crew moment na naman. Kumusta guys? Nandiyan pa ba kayo? Okay, so I hope everything is fine. Kung kailangan yung balikan yung proof later, yeah, you can do so. Kailan di ko nga pala ito i-upload, no? So you can take a screenshot right now. Okay. Tapos, alright, almost done pala tayo. May kulang pang konti. Kailangan natin conclude dito na X is a element ng A bar. Okay? So therefore, we have proven that in either case, X is in A bar, meaning A bar is closed. Kasi laman ni A bar lahat ng kanyang mga limit points. And we're halfway done for the proof of theorem 13. Okay? Mag-add lang ako ng isang page. Kinulang ako na... Okay. Okay, so let's prove the other thing. The other thing is we want to show that A bar is the smallest closed set containing A, all right? And I will do this by contradiction, okay? So proof by contradiction, I will suppose there exists a set B that is closed and has this property. A is contained in B, but B is a proper subset of A closure. Okay? So kasi nga, si A bar daw yung pinakamaliit. So kunwari, i-assume ko na meron pang isang closed set na mas maliit kay A bar na nagko-contain kay A. Tawagin ko yung set na yon si set B. Okay? So pag dinrawing natin yung Venn diagram niya, ito si A. Si A bar ay A union A prime. So mas malaki siya definitely kay A. Tapos yung balance, alright, yung ito nasa yellow region, yan yung A prime. Kasi nga si A bar lang naman, union lang ng A at saka A prime. So lahat ng mga elements ni A bar na wala kay A, sila yung na kay A prime. So yung yellow, siya yung A prime. Okay? Tapos inassume natin na kunwari may isa pang closed set. Tawagin natin siyang si B na nandun sa gitna nilang dalawa. It contains A and it is a proper subset of A bar. Ito si B. All right. So essentially, B contains the all of A, or the entirety of A, plus some of the limit points of A bar. But since B is a proper subset of A bar, then there must be some folks in the yellow region that are not in B. Okay? So that means, so there exists some, say, X element of A prime such that X is not in B. All right? And I think it's apparent from the drawing. May mga elements si A prime na wala kay B. May mga limit points si A na wala kay B. Okay, and this is what we would like to contradict. I want to contradict this statement over here. Okay, let's see. Now, what do we have to work with here? So ito lang yung pwede kong siguro pagsimulan. Merong isang X na element ni A prime, pero hindi siya element ni B. But in the first place, X is assumed to be an element of A prime. That is, X is a limit point of A. So that means, now we know that since X is in A prime, then for all epsilon greater than 0, there exists a Y different from X such that Y is a member, or Y is a member of the epsilon neighborhood around X intersection A. Kasi nga si X ay limit point ni A. Okay, good so far? Okay, so what now? Well, si A, ayan dito. Okay, so ibig sabihin, si Y should live living inside the intersection of these two guys, pero nga si si A ay nasa loob ni si A ay nasa loob ni B. Alright? So kung si Y ay nasa intersection na to, then si Y definitely will belong to this intersection. Okay? Bakit? Kasi ibig sabihin nito, Y element ng epsilon neighborhood and Y element of A, right? Definition ng intersection. Pero definition ng subset, A is a subset of B. So Y element of A implies Y element of B. Tapos definition uli ng intersection. Kaya ako to makukuha. Alright? And what does this mean? Anong ibig sabihin nito? Sige nga. Ano yung implication? Na napakita ko na si Y ay element ng intersection ng kahit anong epsilon neighborhood centered at X and B. Come on, guys. Ano yung pwede kong masabi mula dito? Magkuklo na naman ba ako? For all epsilon greater than 0, there exists a Y different from X such that this statement is true. Yes, Anna.
X is a limit point of B din po.
X is a?
Limit point of B po.
All right, great. Thank you, Anna. Yeah, tama yun. Si X ay limit point ni B. All right? Definition ng pagiging limit point. And then what's next? So, ano ngayon? Kung si X ay limit point ni B, ano pa ba yung ibang alam natin tungkol kay B na hindi pa natin nagagamit dun sa proof so far? Okay? Nagamit ko na yung pagiging subset niya ni A bar. nagamit ko na yung pagiging superset niya ni A, eto na lang yung hindi ko nagagamit. So, pag ginamit ko to dito, ano yung masasabi ko? Sumagot din pala kanina si Jonathan sa chat. Thank you, Jonathan. That's perfect. All right, so now, ano yung pwede kong masabi ulit? Ano yung pwede kong masabi mula rito? X element of B prime at yung assumption na hindi pa natin nagagamit. Sige, Tristan.
Hello, sir. Rinig po ako?
Yep, go ahead.
At try lang po. Since B is a closed set po, it implies na B contains all of its limit points.
Aha.
So, ibig sabihin po, since X is an element of B, since X is a limit point of B, therefore X is an element of B po.
All right, perfect. Thank you, Christian. Tama yun. Kasi close nga siya, laman niya lahat ng limit points niya. Si X, limit point ni B. So dapat si X ay membro ni B. But here, I'm happy because that's a contradiction. That contradicts the fact that we assumed earlier that X is not in B. All right? So therefore, this belies our assumption that there exists a set B that satisfies these two properties. So therefore, indeed, we can say that A bar is the smallest closed set containing A. And yeah, end of proof. All right. So any questions with that proof? Kakayanin nyo na ba magsulat ng ganyang kahabang proof? So, technically, hindi siya mahaba kasi 1.5 pages lang. Tapos, yung sulat ko pa ay malakas kumain ng space. Alright. Pero ang dami na nangyari, no? Pwede na natin tong klase for 1.5 hours. So, yeah. Okay. So, siguro let's have 2 minutes of break. Hinga-hinga lang tayo ng konti. Stretch. Tignan ko yung susunod. Okay, good. At pala next time may pa-music tayo no habang nag-stretching. So we'll start 3:22. Yes, Tristan.
Hello, sir. Okay lang po ba ang ibalik ko dun sa second part ng proof ng theorem 1.13? Screenshot lang po. Thank you. Okay na po for my part, sir. Thank you.
All right, you're welcome. Kumusta ba sa mga lugar nyo? Nararamdaman nyo na ang summer? Tapos ang init nga pala sa Pilipinas, no? I think this is my first summer back here in the Philippines. So, ganito nga pala dito pagka summer. Yeah, actually, Charles, tama yan. Sabi ni Charles, may mga araw na sobrang mainit, tas biglang uulan kinabukasan. Actually, parang hindi na nga nagte-24 hours eh. Parang kahapon ng tanghali, super init. Nandito ako sa Kalawan, Laguna. Tapos nung mga 3 p.m., ang lakas nung bagsak ng ulan. So, hanggang gabi na. Tapos ngayon, akala ko uulan ng malakas, kaya kinakabahan yung internet ko. Tapos biglang super init naman ngayon. Hindi ko pa nasisimulang checkan yung mga nagpasa na ng homework 3. So, siguro gagawin ko siya bukas. Unahin ko siguro yung lab ng mga 175 students ko. Ay, sorry, nakapag-announce ba ako about NCOE celebration? Hindi. Kalimutan ko yata. Hindi, ano? Hindi ko pa na-announce sa inyo. Or hindi nyo na rin malalagawa ng proof na ginawa natin. But I think we haven't talked about it, right? So because the institute, IMSP, will be celebrating its anniversary for being founded as as being founded as a national center of excellence in the basic sciences. I think we are one of only 7 in the entire country. Parang 7 lang, but you need to fact check me on that. I think 7 national centers of excellence in the basic sciences in the entire Philippines. We are one of 3 here in UP Los Baños. So we'll be celebrating this anniversary by some events in the following in the coming Mondays. So first off would be on the 21st of March, merong student, alumni, faculty forum or faculty conference on Monday. So if you don't have anything very important to do, so I suggest you attend that conference or that forum. So check nyo na lang dun sa social media accounts ng institute o ng division para sa mga detalye. Pero if you will attend that, write a short reflection or reaction paper. Just a half page or a full page will do. Walang specific format, honest to goodness reaction or reflection or whatever you want to say about it. So I'll give you little bonuses to the upcoming problem set para doon. Okay? And then on the 28th, meron pang isang activity. That's the research webinars. So I would like to invite you to attend yung presentation ng mga research clusters ng Mathematics Division. So all of the research clusters, I think, will present something on Monday. So I want you guys to do for certain bonuses or for some bonuses sa problem set number 1, I mag-react about at least 2 research clusters. Of course, bakit dalawa? Kasi I know that some of you already have elected or majors. Yung iba alam ng operations research or alam nilang sa biomath sila. Yung iba alam nila sa numerics sila pupunta. And I imagine that since you're interested in those fields, then you will be paying attention to their presentation. But in the spirit of interdisciplinarity and collaboration, I invite you to watch the presentation for another research cluster, different from what you are essentially leaning towards to. So tingin kayo ng dalawang research clusters and then give me your assessment or how do you feel about the things that they presented. Okay? So, and then sulat nyo lang yon as, again, 1 page or half page. Actually, wala namang page requirements, so bahala na kayo. And then I'll give you another bunch of bonuses for the first problem set. And then there's another Monday na meron pang isang event, and I think that would be the job fair or the job summit. Okay? Though siguro kung seniors na kayo ngayon, you might be interested in joining that. Pero hindi na ako magbibigay ng bonus para dun sa third event na yun. But if you still want to come, then you're most welcome to come. Especially if you're looking for, kung hindi man kayo naghahanap ng trabaho talaga, baka maghanap kayo ng internship or ng company for a practicum this coming mid-year. So it would be nice to join that event as well. Saka para makita nyo ano yung mga posibleng trabahong pupuntahan nyo. Kung nandun pa kayo sa verge na itutuloy ko pa ba to? Lolokohin ko pa ba yung sarili ko na gusto ko sa math program o gusto ko sa applied math program or itutuloy ko pa ba tong MS kong ito? So ibig sabihin, para magkaroon kayo ng idea, ano yung mga posible nyong tahakin after your university life, okay? Or ano yung mga opportunities that awaits undergraduates and master's graduates with a degree in mathematics, okay? So yun yung patalastas. All right, now let's continue back to main programming. So theorem 14. By the way, before going here, merong ilang mga properties yung open and closed wala pa tayong binibigay na relationship between an open set and a closed set. Tapos papabulaanan ko na, sasabihin ko na sa inyo na hindi totoo na kapag ka ikaw ay open, ibig sabihin hindi ka na closed. Kung ikaw ay hindi open, hindi nun ibig sabihin na hindi ka closed. Alright? So we need to be very careful about our semantics here. Walang sinabi na a set is closed if and only if it is not open. Or the other way around. There's nothing like that. Dinefine natin yung pagiging open, dinefine natin yung pagiging closed ng magkahiwalay. Ibig sabihin, there is some dynamics between these two guys, hindi nga lang yung obvious na parang pinto. Alright? Hindi, pinag-usapan natin, hindi sila mga doors. Alright? They are mathematical objects. So, kaya iba yung konsepto ng pagiging open at pagiging closed. Meron nga mga set na hindi sila open at hindi rin sila closed. Halimbawa, yung half-open, half-closed interval. Alright? Hindi yan open kasi hindi lahat ng points niya ay interior. Si B ay element ng interval na to, pero si B, meron lahat ng epsilon neighborhoods niya ay hindi subset ng set na to. So hindi siya open. Pero hindi rin naman siya closed kasi si A ay limit point ng set na to, pero si A wala naman dun sa set. Alright, so this interval doesn't contain all of its limit points, namely A. Alright, so hindi siya open, hindi rin siya closed. Meron naman mga sets na closed at saka open at the same time. Halimbawa si R. Okay? Si R ay open. I guess na example na to before. Kasi pag kumuha ka ng kahit anong epsilon neighborhood around any real number, subset pa rin yun ni R. So, ibig sabihin, lahat ng real numbers ay open set, ay interior points ni R. Meaning, R is open. Tapos si R din ay closed. Kasi laman niya lahat ng limit points niya. Kasi nga, siya na yung universal set natin dito. Okay. So, ibig sabihin si R ay closed at saka open at the same time. Another example is the empty set. The empty set is a set that is always closed and is also, di pala always. The empty set is an open set and a closed set at the same time. Okay? So ito yung mga special cases. But in general, ito yung relationship between an open and a closed set. Theorem 14. A set O is open if and only if its complement is closed. Yung OCI complement ni set O. Similarly, a set F is closed if and only if its complement is open. Okay? Si O ay open kapag ka yung complement niya ay closed. Ganun din yung pakabila. So, ito yung tamang characterization ng isang open set in terms of another closed set and vice versa. So, again, this is a actually dalawang statements yung nasa theorem. I will try to give you the proof of the first part and then this would be left as an exercise, okay? Try nyo na lang na sagutan yung part na yan. Okay? Pero gagawin ko yung una. Tapos i-pattern nyo na lang yung gagawin nyo. Marami kayong makikita sa internet na proofs nito, alright? Pero I want you to try to write it on your own, possibly based on what we did today for open sets. Okay? But proving this statement is not a walk in the park because it's an if and only if statement. So we need to prove it in two parts. All right. First, I'll start with the forward direction. So here I will assume that O is open. Okay. And we want to show that O complement is closed. All right. So ito yung gusto kong ipakita. Now, how do I show that a set is closed? Ito yung gusto ko kasing ipakita. Closed dapat yung set. Yung set ay magiging closed kapag laman niya lahat ng limit points niya. Alright? Dapat laman niya lahat ng limit points niya. So, ang gagawin ko, magko-consider ako ng isang limit point ni O complement. Let X be a limit point of O complement. Alright? Tapos gusto kong ipakita si X ay nagbe-belong kay O complement para masabi na closed siya kasi laman niya lahat ng limit points niya. Alright? But I tried the direct proof and it's not pretty. So i-try ko yung contradiction. Mukhang mas madali yung proof by contradiction here. So I will suppose that X is not in O complement. That means, okay, X is in O. All right, so proof by contradiction, ayun yung supposition. I want to draw a contradiction. Now, X is an element of O, but O is open. Ibig sabihin si O ay interior point, right? So therefore, there exists an epsilon greater than 0 such that the epsilon neighborhood centered at X is a proper subset of O. All right? Ito yung definition ng pagiging open. Kasi by assumption, si O ay open. So, ibig sabihin, lahat ng elements niya ay interior. Ibig sabihin, sa bawat element ni X, may makikita kang epsilon neighborhood nun na properly contained kay O. Alright? Okay. Now, anong ibig sabihin na to? So, nakakita tayo ng isang epsilon neighborhood ni X na exclusively nasa loob ni O. So, ang ibig sabihin yan, yung intersection na to ay empty. Do you agree? Kasi lahat ng laman ng epsilon neighborhood ay na kay O. Ibig sabihin, pag kinuha ko yung intersection ng epsilon neighborhood at saka ni O complement, wala dapat yung laman. Alright? Kasi nga lahat ng laman nung epsilon neighborhood ay na kay O. Ito ay yung lahat ng wala kay O. So yung intersection ay empty, but I say, that's the contradiction I'm looking for. Why is that a contradiction? What exactly are we contradicting here? Sige nga. Antay tayo ng iba, Tristan. Habang nag-aantay ng iba. Hindi ko sure, Tristan, kung saan pwede mag-register. Check mo na lang dun sa Facebook pages ng division. I don't know kung nag-announce na sila, but yeah, I think an announcement either is forthcoming or nandun na siya. Nakasagot na rin si Perlin eh. Sige, si Perlin na lang muna. Kasi nakadalawa ka na yata, Tristan. Go, Perlin. Ayan, may sagot din si Charles. Pero sige, Perlin, go ahead.
Hindi ko po sure. Pero po, sabi po kasi kanina ay let X be a limit point of O complement. Tapos, ngayon po may statement tayo na si X ay proper subset ni O. Tama po ba?
Right? So basically, yeah, tama ka. Kino-contradict nito yung pagiging limit point ni X ni O complement. Kasi di ba para maging limit point ka, kahit anong epsilon neighborhood, dapat meron nakapaligid sa kanya na element ni O complement. Pero this statement is telling us na merong epsilon neighborhood, si X, na walang lamang members ni O complement. Sabi nga natin, limit point siya ni O complement eh. So therefore, that's the contradiction there. All right. So thank you, Perlin. The fact that X is a limit point of O complement. Right. So we're done with the half with half of the proof. So we can say therefore, O complement is closed, or is a closed set in R. Yeah, tama rin yung sagot ni Charles dun sa comment section. All right. Now, the converse, prove natin siya. So, naman sa converse, we will assume that O complement is closed, and we want to show that O is open. Okay, and I think here a direct proof will be easy. Okay, so gusto ko lang ipakita na si O ay open. So let's consider an X in O. Okay, so this means X is not a limit point of O complement. Kasi nga si O ay closed, si O complement ay closed. So laman niya lahat ng open sets niya. Si X ay wala kay O complement. So imposible na si X ay maging limit point ni O complement. In other words, we can find an epsilon greater than 0 such that the epsilon neighborhood around X intersection O complement is empty. Kasi nga si X ay hindi limit point ni O complement. So merong neighborhood si X na walang kalaman-laman na member ni O complement. Okay? Pero dahil si X, yung epsilon neighborhood, ay walang laman na member ni O complement, isa lang yung ibig sabihin yan. Ibig sabihin yan, yung epsilon neighborhood ay subset ni O. Okay? Kasi nga, non-empty naman yan. Empty yung intersection. Wala silang elements in common. So, ibig sabihin, lahat ng elements nito ay naninirahan sa loob ni O. Okay? So, ibig sabihin, ito ay subset ni O complement. So, here, for any X belonging to O, we have found an epsilon neighborhood that is properly contained in O. That means X is an interior point. Ang notation nga pala natin sa interior point ay A to the 0, okay, or A to the O. So therefore, we can conclude that O complement, that O is open. Okay. Yeah, paliitin ko lang para ma-screenshot nyo siya. Sama natin yung theorem. Okay, there you go. All right, questions. Ramdam mo nga na summer ngayon, mas nakakatuyo ng lalamunan yung salita ng salita, no? Okay. I think we have one more theorem. Pero last theorem na to, hopefully. Pero yeah, one last na to. So itong theorem na to ay kamukha naman nung isang theorem natin from before. Let me see. Nandun pa ba siya sa aking... wala na. Kamukhang ka, sorry. Bear with me. Scroll up lang ako. Yeah, there you go. Theorem 12 yata yun. Okay, there you go. Kapain ko lang to sa baba. Okay. All right. So theorem 12, the proof of which was shown in the video I asked you to watch. All right. So kamukha siya ng theorem 15, but theorem 12 talks about open sets while theorem 15 talks about closed sets. And then if you have watched the video, you might have noticed that the proof of theorem 12 is quite tedious. Maraming ginawa kasi by definition lang ng pagiging open yung pinaglaruan natin. Right? Kaya medyo maraming mga nangyari ron. However, okay? However, sa theorem, pwede ako mag-take advantage ng theorem 14 para sa proof ng theorem 15. Para hindi ko na daanan or hindi na ako ma-force na gamitin lamang yung definition ng pagiging closed para ma-prove ito. Okay, but you can write a proof similar to the proof of theorem 12, pero bakit ako magpapakahirap if I can take advantage of the results from theorem 14, okay, and theorem 12 as well. So how will you be able to take advantage of that? Okay, papakita ko by proving this part. And then you can try proving the other part, okay, in part 2. Okay. And sabi sa part 1, the union of a finite collection of closed sets is closed. So ibig sabihin, magko-consider ako ng mga closed sets. So consider F1, F2, hanggang Fn, be closed sets in R. Okay. Tapos balikan ko nga yung theorem 12. Sabi ni sir, mag-take advantage ng theorem 12. Alin dyan yung nag-involve ng finite sets? Oh, finite collection is covered by theorem 12. Kaya lang, finite intersection ang theorem 15 talks about finite union. Pero remember, we characterized open and closed sets using their complements. All right? So kaya yung union nagiging intersection pag nag-complement and vice versa. So yun yung gagamitin kong trick para ma-prove ito. Okay? So now, if these guys are all closed sets, then it follows that F1 complement, F2 complement, until Fn complement are all open by theorem 14. Okay? Tapos, sabi ng theorem 12, kunin ko yung finite intersection. Okay? So sige nga, kunin ko yung finite intersection. So by theorem 1.12, so yung intersection. Yung intersection ng F1 ng Fi complement, I going from 1 to n, okay? Dahil bawat isang Fi complement ay open, so yung intersection nila ay open din. All right? Finite intersection of open sets is open. Now, ayoko yan. Gusto ko ay finite union ng mga Fi's. Pero I'll just simply take the complement of this guy. Kunin yung complement nito dahil ito naman ay open, so yung complement niyan ay closed by theorem 14. So, I'll take the complement, itong guy na to, at alam ko ang sagot na yan, ang sagot sa complementation na yan ay closed kasi complement siya ng isang open set. But if I do the calculations, I will use De Morgan's law. So yung intersection nagiging union. Tapos Fi complement. Pero ang complement ng complement ay yung original set. Okay? And again, we knew by theorem 14 that this is closed. By theorem 14. Okay? And we're done. At least for part 1. So I hope you can imagine how to write the proof para naman dun sa pakabila. Alright? Pero napaka-similar. Ganto yung gagawin nyo. Ito yung idea. De Morgan's law ang kasagutan yun sa proof na yun. Okay? Now, yeah, I saw some reactions. So thank you guys. So mukhang madali lang siya. If you need a screenshot, then you can do so now. So, kahit may 5 minutes pa, sabi na akong mangungutang ako siguro ng additional 5 to 10 minutes. Baka sagarin ko hanggang 4. Para matapos na natin itong lecture notes 1. Para ready na kayo mag-problem set sa Thursday. Okay? So, tapos na yung section 1.8 and we will cap... Sorry, hold on. Sorry, nasa mid ako dun sa iniinom kong kape. So now, okay, let's go to section 1.9. So we will cap off the unit by looking at some more definitions, right? So siguro 3 or 4 na definitions na lang naman ito. Okay. Now, earlier we were talking about limit points and isolated points sa mga closed sets. Sabi natin ng isang set ay closed kapag laman niya lahat ng kanyang mga limit points. But that's a very distinct statement. Hindi naman natin sinabi na kapag ang isang set ay closed, ibig sabihin lahat ng laman niya ay limit points. Halimbawa, itong set na to, si F, ay halimbawa yan ay closed set. Alright? Laman ni F lahat ng kanyang limit points. Pero the converse is not true. Hindi ibig sabihin lahat ng laman ni F ay limit points. Posibleng may mga isolated points sa loob ni F. Okay? But if your set is very, very nice na siya ay closed, tapos wala siyang lamang isolated points, ang tawag sa kanya ay perfect set. Okay? So sana all perfect, no? Pero sa mga sets, ito yung pamantayan ng pagiging perfect. Perfect ang isang set So wala ditong masyadong bolahan na sabihin nyo perfect lang yung crush nyo or something. Alright? Kasi para maging perfect ang isang set, dapat siya ay closed at saka dapat wala siyang isolated points. Kita nyo sa math, no? Napaka-defined ng lahat ng mga bagay-bagay. So quick examples of perfect sets are are closed intervals. So yung mga usual closed intervals na more than one yung laman, sila yung mga perfect sets. Okay. Now, kung merong mga perfect, meron din naman mga hindi perfect na sets in such a sense na separated sila. Nagawang kagad ng kwento. Anyway, so kailan naman nagiging disconnected o separated ang isang set? So simulan natin sa pag-uusap about separated sets. Meron kang dalawang non-empty sets. Sila ay separated kapag yung closure ng isa, intersection yung kabila ay empty. So that means A and B will be separated if and only if A closure intersection B and A intersection B closure are both empty. Now, this is more restrictive than just being disjoint. Okay? Hindi lahat ng disjoint ay separated. Pero pag separated ka na, dapat disjoint kayo. Kasi pag hindi kayo disjoint, ibig sabihin, hindi ka magiging separated. Pag hindi ka disjoint, hindi ka na pwedeng maging separated. Sorry guys, meron ng urgent call. I need to answer this. Sorry. All right, sorry for that. Merong magdi-deliver. Hindi makapasok sa bahay. Pero yan, nasa na nga ba ako? Ayan, separated. So, mas restrictive to kesa sa pagiging disjoint. Pag disjoint ka, hindi ibig sabihin separated ka na. Pag hindi ka disjoint, automatic hindi ka separated. Pag hindi ka disjoint, hindi ka separated. So, ano yung example? Halimbawa, yung interval 1, 2 pero open dito at saka yung 2, 5, okay? Itong dalawang sets na to ay obviously disjoint. Wala silang common elements. Kasi ang posible lang maging common element nila ay si 2, kaya lang si 2 ay wala rito. Kaya lang, pag kinuha natin yung closure nito, pag kinuha ko to, ang closure nito, closed interval 1, 2, intersection this guy, walang problema, empty. Pero pag kinuha ko naman yung closure nito, ang closure nito ay closed interval 2, 5, in intersection ko dito, non-empty na. Right? So ito yung isang example ng dalawang disjoint na sets pero hindi sila separated. May pag-asa pa silang magkabalikan. Alright, parang ganon. So, meron pang bind na nagtatali sa kanilang dalawa at yun si 2. Si 2 yung nag-hold together. Ang corny ng mga analogy ko ngayon. Ano nangyayari ngayong araw? So, ayan. Parang ganito yung drawing yan. Yan. Okay. Parang si 2, kumakapit pa siya dun sa relationship ng set A at saka ni set B. Alright? So, hindi sila separated, pero disjoint sila. May pag-asa pa. Pero kapag sila ay separated na, for instance, si open interval 1, 2, at saka si open interval 2, 5. Alright? Pag dinrawing mo yan, okay. 1, 2, 2, 5. Alright? Wala na silang pag-asang magka-reconnect. Kasi hindi lang walang nagjo-join sa kanila together, wala na nagtatry kumapit dun sa relationship nila, pero may humahad lang na. Meron na nagse-separate sa kanilang dalawa. Si 2 na ang tumatayong malaki sa pagitan ng dalawa. Alright? Mathematically, the closure of the open interval is a closed interval 1, 2. Its intersection with the open interval 2, 5 is non-empty. The converse also has the same property. The closure of the open interval 2, 5 is a closed interval 2, 5. intersection, the open interval 1, 2, the intersection is still empty. All right? Basta para ma-check kung sila ay separated, dapat kunin mo yung closure ng isa, i-intersect mo dun sa original ng pangalawa. All right? Now, that's what is required to become separated. Okay? Now, kailan nagiging disconnected ang isang set? Ang isang set ay nagiging disconnected. All right? A set E is disconnected if you can take it apart as a union of two separated sets. So yung isang set E, pag na-partition mo siya sa dalawang parte na separated, ibig sabihin siya ay disconnected. Okay? So yun yung technical term para sa disconnected. Tapos, sir, ano naman yung connected set? Pag hindi siya disconnected, siya naman ay connected. Yun yung definition 15. And this will make you appreciate yung pagiging clear ng semantics sa mathematics in general, right? So pag walang ganitong klaseng definition, hindi kayo pwedeng umasa na pag hindi siya closed, ibig sabihin ba open siya? Kahit hanapin niyo yung lecture notes, wala akong sinabi na a set is open if and only if it is not closed. Pero pwede niyo sabihin na pag hindi siya disconnected, siya ay connected because of definition 15. Right? And this is usual. We don't usually define what a connected set is. Dinidefine natin muna kung kailan siya disconnected. Pag hindi siya disconnected, saka siya connected. All right? So for instance, the union of these two sets is what? Hindi, papa-homework ko na lang pala yun. All right. So, no spoilers na lang muna. Okay, and then last, bago lumabas si Gordon Ramsay. All right. So, definition 16, kailan naman siya nagiging boundary point? Ang isang point ay, oops, baba natin siya, na-spoil na siya. So, ang isang point ay boundary point kapag lahat ng epsilon neighborhood niya ay laging may element ni A at saka may element ni A complement. Kaya siya boundary. And this is quite easy to understand why. Siguro kahit sa layman, may makasalubong kayong mama or ale paglalakad nyo mamaya. Kaya, tanungin nyo, halimbawa yan set A. Sige nga, turo nyo sa akin ano yung mga, magbigay kayo ng isang boundary point ni set A. Of course, instinctively, people will tell you, something like this is a boundary point. Okay? Kasi siya nga yung nasa boundary. Bakit nga siya yung boundary point? Siya nga kasi yung nasa boundary. Respect my opinion na lang, no? Parang ganun. Pero anyway, paano natin siya maka-quantify na siya talaga yung boundary point? Kasi hindi tayo pumapayag na respect my opinion lamang. So, kailangan natin siyang bigyan ng tamang definition, right? Ang definition natin kanina, kahit anong epsilon neighborhood around that point should contain elements both of A and A complement. So pag nag-drawing ako dyan ng epsilon neighborhood, remember sa 2D, ang epsilon neighborhood ay laging open balls. Alright? So kahit gaano man kaliit o kalaki, yung circle na idodrawing ko na yan, yung open circle na yan na idodrawing ko, laging may mga parts yan na nakay A, laging may mga parts na nakay B. So indeed, that would be a boundary point. Pag nasa interior siya, hindi siya pwedeng maging boundary point. Kasi nga kung interior point siya, by definition ng interior point, may makikita ako na isa. At least isang epsilon neighborhood na properly contained kay A. So ibig sabihin, hindi na lahat ng epsilon neighborhood around this interior point will contain elements of A complement. Kasi ang problema, ang definition ng pagiging boundary dapat for ayan, sorry, naputol yata ako. Hopefully, nakabalik na ako. So, yung mga interior points, hindi na siya pwedeng maging boundary point kasi nga there exists an epsilon neighborhood around interior points that are properly contained in A. Ang usapan sa boundary point dapat for all. Ganun din yung mga nasa labas. Pag nasa exterior ka, mayroon diyang maliit na epsilon neighborhood na walang elements naman ni A. So, hindi ka pwedeng maging boundary point. Tapos pag kinolect natin lahat ng boundary points ni set A, ang tawag natin doon ay boundary ni A. And the boundary of A is denoted by this symbol, partial of A. Okay, ang basa natin dito ay boundary of A. And then, pasok na Gordon. Finally, we have finished lecture notes 1 or unit 1. Masyadong premature yung mga puso-puso nyo kasi ibig sabihin yan, may problem set na tayo. Alright? So I'll give you the problem set on Thursday and then you will submit it on Wednesday next week. Alright? Pero wala naman tayong homework para sa week na to. Okay? So probably I'll think about the problem set tomorrow. Okay? And then I'll give you some okay, I'll give you some more details on Thursday na lang. Okay? So any questions, guys? So if there are none, so thank you guys for coming today. Thank you for participating. So lahat ng mga nag-recite, don't forget to, at least yung mga nag-recite verbally, don't forget to drop a comment with your nickname. And then yon. Ano yung pinadeliver? Humirit yung, hindi naman siya actually para sa akin. Humirit yung tita ko ng bike. So, nag-deliver ng bike ngayon. So, buti na lang may magre-receive sa labas. Alright. So, anyway. So, thank you guys for coming. Enjoy the rest of the day. And let's meet again on Thursday. Okay? Bye, everyone.